Predicting Stock Prices Using Sentiment Analysis by Veronica Warren, David Latimer, and Harold Anderson. Background of the problem. Predictive analytics essentially consists of coming up with different programs to make predictions about the future. This type of data science uses data in all of its phases, from inspecting and cleaning to transforming and modeling. Predictive analytics also uses statistics to validate assumptions and to test hypotheses. Some of the different types of predictive analysis are forecast models, classification models, outlier models, time series models, and clustering models. Forecast models are one of the most common types of predictive analysis models. This is the one we used. Classification models typically use data that can be categorized. Outlier models analyze anomalies, and time series data is where time is the main input parameter. The final type of predictive analysis model are clustering analysis models that take data and sort it into different groups. Sentiment analysis is a form of predictive analytics that uses textual data like texts and emails to learn more about a product or service. In our case, we used social media tweets or a brief message on the Twitter website to learn about stock price behavior. Sentiment analysis, or NLP, natural language processing, or opinion mining, focuses on polarity like positives and negatives and neutrals to gauge brand sentiment and to analyze customer feedback. There are several different types of sentiment analysis. First is fine-grained sentiment analysis, which focuses even more on polarities. This type is often seen in polls and surveys with the 5 categories like very strong, strong, neutral, weak, very weak, or like in our case, positive, neutral, and negative. Second is emotion detection, which uses lexicons and word associations to learn about underlying emotions. This is particularly prone to error, however, because of sarcasm and ways people express emotions differently. Third is aspect-based sentiment, which is used to hone in on a certain aspect or identifier. This is used to learn more about which product features or service aspects people are mentioning. Last is multilingual sentiment analysis. Some examples of this are language translation programs. Some of the benefits of sentiment analysis are its ability to process huge amounts of data in an efficient and cost-effective way. 90% of the world's data is unstructured, meaning untouched and raw, and usually text-driven. Examples would be emails, support tickets, chats, and social media. Speed is the key to survival in business and is another benefit that sentiment analysis studies and provides. It not only allows analysis of this type of raw data, but it does it in real time. Is a client about to leave the company? Let's send a promotion right now to stop it. Is a PR crisis taking over social media channels? Let's take that product down that caused it. These are some of the quick decisions companies need to make on a regular basis, and sentiment analysis facilitates this. The third benefit of sentiment analysis to businesses is consistency. By using the same program for each department, this allows greater cost savings. For our purposes, we wanted to see if there was any recent correlation between stock price movement and social media posts. We wanted to figure out if sentiment analysis could be useful in this regard. Once we were able to calculate correlation, we wanted to find out if there were any real-world uses. We wanted to see if we could build a model to make money on these stock price movements. Methodology. The first step involved collecting tweets. For this, we had to run multiple codes multiple times to gather all of the unstructured data. This data had symbols, it had capital letters, and duplicates, and overlapping tweets that we needed to weed out. Then, using math coding, we took the mean of each tweet falling within half-hour intervals. The companies we picked were Tesla, Facebook, Charles Schwab, AT&T, and Dogecoin. To give a brief history of the different types of stocks we picked and how they differed in industries and operations, I will go over each one. We did these different stocks in different industries to give us a broad reach across several different sectors of the economy. Tesla was founded by Martin Eberhard, but is best known by its primary investor, Elon Musk, who bought into the company with $6.35 million of his own money. It is named after the famous inventor Nikola Tesla, who was a pioneer in electricity. Dogecoin was created by software engineers Billy Marcus and Jackson Palmer. This is one of the new cryptocurrencies being traded today and was initially created as a joke. The logo is the face of a Shiba Inu dog. Facebook was the creation of Mark Zuckerberg, who came up with the concept while a student at Harvard University. The movie The Social Network depicts the history behind the formation of the company, whose membership was limited at first to Harvard students, but then expanded to other colleges and then the world. These were our results. Our results for Tesla were varied. Some days, sentiment and stock price seemed to be directly correlated. Other days, they ran in different directions. This being a technology company traded on the stock exchange, we could only use data from 9:30 to 4 Eastern Time. For some reason, we weren't able to surmise correlations between the tweet sentiment and the stock price strengthened on downward slides of stock and sentiment, then upward moves. Dogecoin, being a currency not trading during specific hours of the day, was a little easier and the correlations were a little closer. Again, we witnessed an increase in correlation on downward or negative sentiment than on positive sentiment. Challenges to this project came mostly in the accumulation of the required amount of data. As mentioned earlier, the stock prices we were only able to gather during open market hours, while the tweets were 24 hours per day. We were also limited on the tweets collection because of the open source software we were required to use because of its free access. This required constant running of the program and then deletion of the overlapping and duplicate tweets. The second challenge, as mentioned earlier, was very time consuming and required manually writing down stock prices for every 30-minute block throughout each trading day. Some of the stocks showed challenges, like Facebook and Schwab only gave 0 values, while AT&T gave us date-time conversion problems. What we would do differently: have a wider variety of stocks to look into and keep track of them across a longer timeline. Having more stocks would also avoid looking at stocks that are dropping in price like these were, and looked into shorter and longer time intervals to compare with price to see if anything lined up. To avoid many of our issues, the premium Twitter APIs would be very useful as well. This would allow us to run the code just once. No duplicates or overlapping tweets would be gathered, and we would be able to get more than a month worth of tweets if we wanted. By more than just 2 weeks of data, we could find more patterns and play with more time intervals. This project was a great learning experience. Based on the results, it looks like there is some correlation. We would have done several things differently if given the opportunity to further our research. As mentioned before, some of the things we would have done differently would be to add more companies to our research. We only hit several sectors of the stock, publicly traded stocks, and adding stocks from utilities, from the financial sector, and from other sectors, we would have gotten even a broader reach to add to our data and to our research. We would also pay for the premium Twitter API to be able to retrieve more data. Just using the open source software, it gathered about 6 days worth of data, depending on the type of company. And by using a premium Twitter API, we could have expanded our data going back to several weeks or even several months. And this ties into our not having to run the code more often than we did with this project. But all in all, we were able to learn text-based research and converting to actual positive and negative sentiments